In this video, we will show you how formalized requirements can dramatically improve the efficiency and completeness of software unit verification. Please have a look at our video on formal specification to find out how these requirements get created. We will mainly look at three use cases: formal test, requirements-based test generation, and formal verification using model checking technology. Let's start with formal test. In a traditional requirements-based testing approach, each test case is only checked against the requirement from which it is derived. But what if test case number 2 violates requirement number 4? Thanks to formal test, all formalized requirements are automatically checked against all simulations. The status is reported for all execution levels, like mil, sil or pil. In this example, the test cases linked to requirement 1.1 are passing, but the formal test discovers a violation of requirement 1.1 coming from a completely unrelated test case. In addition to showing if a requirement has been violated, we also introduce a meaningful metric for requirements coverage, allowing to see if a requirement has been partially or fully tested. If a requirement is not fully tested, our second use case allows you to automatically generate missing test cases from the requirements. On this example, we start the test generation for requirement 4.1, and we can see that one test case is enough to deliver 100% requirements coverage. After a simulation, we can see that the formal test status has changed from inconclusive to fulfilled due to the newly generated test case. But how to guarantee that a safety requirement can never be violated? As Dijkstra put it, testing shows the presence, not the absence of bugs. So this question cannot be answered by testing, as a test case only represents one out of an almost infinite number of possible runs through the states of a system. The answer is a technology called model checking, which analyzes all possible runs at once. The result is either a mathematical proof that a requirement can never be violated, or a counterexample showing how to bring the system into a state that violates the requirement. In this example, our safety requirement can be violated in 4 simulation steps. From the counterexample test case, we can now generate a debug environment, identify and fix the problem, and run the proof again. Please also have a look at our other videos and don't hesitate to contact us if you have any further questions.